Hello everyone. Understanding a new codebase is often one of the most difficult tasks for developers. Large repositories can contain hundreds of files and complex dependencies, making it harder to quickly understand how the system is structured. CodeMRI solves this problem. CodeMRI is an AI-powered repository analysis tool that scans a GitHub project, builds a dependency graph of the entire codebase, and generates AI-driven architecture insights and scaling risk analysis within seconds. The interface is simple. The user just provides a GitHub repository owner and repository name. For this demo, I'll analyze this repository. Now I'll click send. Before showing the results, a quick note about the system design. In the initial version, CodeMRI used a multimodal AI agent to explore repositories. The system launched a Playwright browser, captured screenshots of the GitHub repository page, and sent those images to Gemini. The AI then decided actions like opening folders or files to explore the repository automatically. While this worked, it introduced significant latency because every step required a screenshot and AI reasoning. So we redesigned the system. In the final architecture, we replaced the browser agent with a direct GitHub API pipeline. The backend retrieves the repository tree, downloads Python source files, and passes each file to extract import dependencies and module relationships. These results are stored in Google Firestore, allowing us to reconstruct the repository architecture quickly. Once the analysis is complete, CodeMRI generates a dependency graph of the repository. Each node represents a file and edges represent important relationships between modules. The graph is built using NetworkX, which allows us to analyze structural dependencies and architectural patterns in the codebase. This helps developers immediately understand how the project is structured. Now, the system runs a scaling risk simulation on the dependency graph. It evaluates signals like module coupling, database concentration, dependency centrality, and presence of caching layers. These signals are combined to compute an overall scaling risk score of the repository. Finally, the analysis metrics are sent to Gemini 2.5 Flash, which generates an AI explanation of the architecture. The AI explains the scaling risk and provides recommendations. For example, in this repository, the AI detected that no caching module is present, which could increase database load under high traffic. The model is constrained to analyze only the extracted repositories metrics to avoid hallucinations. The system of let's go to the system architecture. The system consists of a React frontend, a fast API backend, a repository analysis pipeline, dependency graph analysis, and Gemini powered architecture insights. In summary, CodeMRI transforms complex repositories into clear architectural insights by combining dependency graph analysis, scaling simulations, and AI explanations. It helps developers quickly understand unfamiliar code bases and identify potential architectural risks. Thank you.